Number 6, we're asked to first, given this vector value function, and we're first asked to sketch its graph. So we'll get something coming out so that we can see that y is equal to x. That's the line that goes through the middle of the floor here. So on the floor, it would be that line going right through 45 degrees. But we see that the z coordinate is actually going to be the sine graph is going to be being graphed on this line in the z direction. So what I'm going to have is sine starts there and it's going to go up and come underneath and then go up, so forth, in both directions. So it's going to go underneath and come back up, so forth. So you just have a sine that's winding its way through that first, well, on the floor through the first octant and that other octant back there. Now we want to compute r prime of pi and t of pi, the unit tangent vector of pi. Well, r prime is simply just taking the derivative of each component. That is 1 cosine t. And if I want to evaluate that at pi, I just plug it in. I get 1 cosine pi, and cosine of pi is -1. So this is 1 -1. To get the unit tangent vector, I need to find the magnitude of r. The magnitude, supposed to be just one line there, is the square root of 1 squared plus 1 squared plus cosine squared. And I want the, so what I get for t at pi is r prime at pi divided by the magnitude of r prime at pi. In general, you just have t here, but I just asked for the one value. Well, r prime at pi, we just calculated, is 1 -1, and the magnitude, just plugging pi in here, we get square root 1 plus 1 plus cosine squared. Well, we just did cosine pi squared. That's -1 squared, which gives me square root of 3 there in the bottom. So this turns into, since this is going to be square root of 3 here in the bottom, I get 1 over square root of 3, 1 over square root of 3, and -1 over square root of 3. That's the particular unit tangent vector at pi. And then the last, here it asks me to compute the derivative of this dot product. I'm going to go back up. It's t and sine t. So I'm what I'm taking the derivative of is the dot product of t and t sine t. Now there is a product rule, but I really don't have to use it. I can just take the dot product and then take the derivative of whatever I get. So this is going to be the derivative of that dot product is t squared plus another t squared plus t sine t. And that's just derivative from calculus 1. These two together are 2t squared, so without rewriting the whole thing, now I'll take the derivative. Let me do it underneath. The derivative of 2t squared will be 4t. This will take a product rule because it's t times sine t, so it's the derivative of t times sine t plus the derivative of sine t times t. So sine t, derivative of sine t is cosine t. And that's about as far as you go, so that would be your derivative. All right, number 7, we're asked to find the equation for the line that passes through the point 1, 2, 3 and the point where this other line passes through the xy plane. So I know to write the equation of a line, I need two things. I need a point. Well, they've given me a point, and I need a direction for my line. Well, the way I'm going to get the direction is I'm going to get a second point, and I can take the direction vector between those 2 points as the direction for my line. Well, to get that second point, it is the point where this line passes through the xy plane. That is, it is when z is 0. Well, there's my z component, so I just need to know when that line has a z component of 0. So when is 2 plus t going to be 0? Well, that's obviously going to be when t is -2. And so what is the point that I get? Well, it's going to be the point that corresponds to the point generated by this line when t is negative 2. So I'll generate by plugging in negative 2. I get negative 2, 3, and 0. That is, the point is negative 2, 3, 0. So that's what that vector is pointing at, that particular point. So now I've got these 2 points. I can find the direction vector based on those. It doesn't matter which direction you go. I'm going to go ahead and just say minus 2 minus 1. That's minus 3. 3 minus 2. 0 minus 3. You could also have done it the other way. It just would reverse this vector. You'd get reverse the signs. And you can take any multiple of this that you want other than 0. That would still be your direction vector. But I'm going to go ahead and use this one, and I'll just use the original point that was given, but you could use this point that we generated as well. So the line that that's being described here is going to then have equation in vector form of the coordinate of my point, which is 1, plus this component times t, so that's going to be negative 3t, then 2 plus 1t, then 3 plus 3 plus, which is in this case minus 3t. So that's the equation of the line that's described.